Okay, hello, my name is Tanya Nazaretsky. I'm from the Weizmann Institute of Science, and thank you for attending my presentation today. It's going black.
Oh, sorry. Oh, it's back.
But it's, okay, I hope it will. Okay, hello again. My name is Tanya Nazaretsky, and thank you for attending my presentation today. The title of the work I'm presenting today is Empowering Teacher Learning with AI, Automated Evaluation of Teacher Attention to Student Ideas during Argumentation-Focused Discussion. And it is a joint work with my colleagues from ETS, Jamie Mikeska and Beata Beigman-Klebanov. I'll start with a short introduction. According to NGSS, engaging students in argument from evidence is a major goal of science education. However, teachers often struggle to achieve this complex task. Indeed, it requires efficient management of coherent argument-focused discussion while attending to students' ideas, encouraging student-to-student communication, and developing students' conceptual understanding of the phenomena under the discussion. Previous research confirms that to master these skills, teachers need multiple opportunities to try out this practice. Online simulated learning environments can provide such opportunities for pre-service teachers. The simulated environment that we used in this study was made up of 5 elementary student avatars. It allows teachers to lead a classroom discussion in ways that are less complex than a real classroom, but still very similar to how the students on these elementary levels, elementary grade levels act and respond. The teacher can practice their craft without any risk to real students and repeat multiple times the preparation for the discussion, the engagement with the students, and the reflection on the results. However, to improve the pre-service teacher's ability to facilitate the discussions, they need to receive timely, focused, targeted, actionable feedback. And usually such feedback is generated manually by human experts, and it requires much of expertise and time to produce, so it's hard to scale for many teachers. Previous research confirms that recent advances in natural language processing and machine learning have great potential of analyzing classroom discourse. However, in most cases, these methods employ supervised machine learning, which requires a lot of data, collecting and manually labeling a large amount of data. To mitigate these requirements, in this study, we used a few-shot machine learning. An idea of few-shot machine learning is to utilize the power of large pre-trained machine language models like BERT. Such models can be fine-tuned for specific language tasks using relatively small labeled data sets. And they were shown to achieve satisfactory performance on a large spectrum of language tasks, including discourse analysis. This research is part of our ongoing effort to explore application of machine learning and natural language processing to support teachers in managing argumentation-focused discussion. It should be done in a student-centered way. Especially in this study, we focused on the following research questions. Can AI-powered models accurately score an elementary teacher's ability to attend to student ideas in a simulated argumentation-focused discussion? Can AI-powered models support automated personalized feedback to the teachers to help them improve in attending to student ideas? In this study, we used transcripts of 157 discussions conducted in previous study by 41 teachers in a simulated classroom environment with 5 elementary student avatars. The discussions aimed at improving teachers' ability to move the discussion on in a student-centered way. Especially discussions were focused on identifying the mystery powder based on its observed properties and deciding which properties are most helpful. The simulated students were designed to have different opinions on this subject, and some of them were wrong or inaccurate. The teacher goal was to lead the discussion focused on reaching a consensus by engaging the students into argument-based discussion. Presented here in the slide a fragment from one of the such discussion transcripts to evaluate the effectiveness of teachers' discussion. Experts created a holistic rubric. It was done in previous study too. And in this study, we focused on one of the rubric categories related to teachers' ability to attend to student ideas. In particular, the grading rubric for this category consisted of several, of the total score with several indicators, including the indicator B related to eliciting substantial contribution from all the students, and indicator C related to engaging ability of teacher to engage with student ideas to move the discussion forward. It's essential to mention that raters were also asked to provide not only the scores, but also the justifications for their decisions. And for example, to justify the score for indicator B, one of the raters chose these two utterances, Minas and Carlos utterances, as an examples for students' ability for students' substantial contribution. And to justify the score of indicator C, one of the raters provided this teacher utterance rounded here in the green rectangle. The transcript annotation was also done during the previous study. In particular, 2 transcripts were rated by 12 raters, 56 transcripts by 2 raters, and the rest by 1 rater. In this study, we evaluated several ways to create automated grades in their justifications. To be specific, we considered 2 approaches for automated score generation. The first one was straightforward. It was based on utilizing the text itself of the text of the transcript alone to predict the holistic rubric scores. And we call it text-to-score approach. The second and more sophisticated was we called it evidence-to-score approach, and the idea behind this method was twofold. First, we wanted to utilize the justifications provided by raters for their scores and as additional source of information. And the second, its scoring mechanism was designed to mimic the human rater scoring rubric. Namely, the method was intended to identify all teacher and student utterances that could serve as justifications for indicator scores. So we could combine these justifications to generate the holistic score and could pick several justifications to explain the automated scores. As I mentioned, the data was collected and annotated in the previous study, so the previous study was done with no initial intent to support future process of automation. So the data preprocessing step was required here to convert the data into format suitable for machine learning. And it resulted actually in 4 data sets. The first one, we named it dataset 1, was unlabeled and consisted of all the utterances automatically parsed from all the discussion transcripts. And each utterance was paired with the name of the speaker. As I mentioned before, raters were asked also to justify their scores, meaning the raters pick some of the utterances to serve as positive or negative examples for indicators A, B, and C. And we used these justifications collected from all the raters to create dataset 2 and dataset 3. In particular, dataset 2 consisted of around 1,600 student utterances with binary labels, indicating if this utterance can serve as a positive or negative example of a student's substantial contribution. And as you can see, only 15% of entire number of student utterances were labeled. The rest were unlabeled. Meaning we had no information regarding the labels of the rest of the student utterances. And similarly, DS3 consisted around of 700 teacher utterances with binary labels indicating if each utterance can serve as a positive or negative example of a teacher's ability to move the discussion on. In this case, only 7% of teachers' utterances were labeled. And finally, the dataset 4 consisted of all the transcripts and the holistic scores provided by the raters. The inter-rater agreement was evaluated using all the double score transcripts, 56, and the Pearson R values indicated a fair and moderate level of agreement. which is consistent with inter-rater agreement obtained in various previous studies focused on discourse analysis. However, evaluating inter-rater agreement for justification examples was not an obvious task. Namely, our dataset had 56 double-scored transcripts, but in most cases, the two raters picked very different examples from the same transcripts, so making it very hard to decide about the agreement levels. But would it be different? Would it be different if there were a dozen of raters? In this case, it's reasonable to assume that really good examples will be picked by more raters. So we can assign each utterance a weight equal to the number of raters who picked this utterance as justification. To visualize this data, to visualize this data of utterances weights, we use this pyramid, and the number of levels in the pyramid is the number of raters. And at the base of the pyramid, you see all the utterances of all the speakers, which were picked by only one rater. In our case, 7 raters picked this particular minus utterance, so we would give this utterance a weight of 7 and put it also on this level 7 on the pyramid. However, if you can see, there is another utterance of Mina, which was picked by 11 raters. So we suppose that this is the best example of justification. And so the pyramid score of this rater who picked this minus utterance would be calculated as follows. It would be calculated as a ratio between its weight, the weight of the utterance he picked, and the weight of the best utterance. In this case, we have like, it was there, sorry. 7 divided by 11. Due to time limits today, I'm going to only present the methodology and results of our evidence to score model, and it was the best, it achieved the best results. You are invited to read the paper for the rest of the results and the methods. Our machine learning method consisted of several steps. The first was fine-tuning the BERT classifiers for indicator B and C separately using the small labeled part of dataset 1, namely datasets 2 and dataset 3. Second, we used the resulting models to predict the scores for all scores of indicators B and C for all the utterances in dataset 1. And based on these predictions, we constructed and transcript level features. And finally, we used them together with the human scores to train the regression models for the holistic scores. And here the results. As you can see from the slide, based on Pearson R coefficient, our evidence to score model achieved even higher agreement levels than the human inter-rater agreement. As per research question 2, we used the same approach as research question 1 to create the BERT models for justification predictions using datasets DS2 and DS3. In this case, we considered not only the model predictions, but also the model's confidence on its prediction. And we assume that the positive predictions with higher probability will serve as better score justification examples. So we used all utterances from the 2 multi-rated transcripts, 12 raters, and as a test set to calculate model pyramid scores on the same data set as we calculated human scores, human pyramid scores. And based on the pair two-tailed test, the results indicate that our automated justifications achieved pyramid scores that did not differ statistically from the human-generated scores. Okay, to summarize, previous research confirms the teachers struggle to engage students in argument from evidence. Timely formative feedback can improve teacher skills. We provided a way to automate the evaluation process for teacher-led argumentation practice. We have shown that our automated model for holistic scores achieved human-level performance on this task. And our models also generated automated evidence for the predicted scores, aims to explain and justify the automated holistic scores. Our research main threat was relatively low human inter-rater agreement level. So we plan to collect more human data to prove these results. It's significant to mention that our research utilized human score justifications that were not collected as a formal annotation campaign, but as a bypass of holistic scoring, and showed that their usage could significantly improve the resulting model's performance. It's also essential to mention that our approach was able not only to provide the total scores, but also to explain them explain them in the form of the justifications. In particular, these justifications were used as base for generating real-time automated formative feedback for teachers. And we plan to extend the study to check it with the teachers. These are us. Thank you.